Hi, my name is Jonas Birgersson. I'm here to tell you about something we call EnergyNet. And we believe that this is the way with internetification of the energy distribution system. And we believe that this will be the architecture for a completely new 21st century energy system. But let's go back and talk about digitalization. Let's talk about the enormous gains we've done in other fields, such as communication. And it goes back to the late 1970s, beginning of the 80s with the microprocessor. The Intel 4004 is a really incredible breakthrough, but at the time when it was launched, people thought it was a toy. It was all about supercomputers. But what happened was that it reached an incredible scale, and that scale come from a concept of that everybody could have their own PC. So with the modern PC, the small microprocessor got incredible volume, and we got something that everybody today knows is Moore's law. But what it really was an incredible breakthrough in price performance on compute. And how incredible was that price performance? Well, let's just look at comparable numbers. So in 1975, the world's first supercomputer, the Cray 1, was created. Let's compare that to the most common phone in Sweden currently, an old iPhone 12. If we compare the world's first supercomputer in raw power, actually, you all have a supercomputer in your pocket today because the performance of an old iPhone 12 is actually more than 68,000 times what the world's first supercomputer was. But also, when you look at the price performance for the same amount of money that they invested in 1975 in the world's first supercomputer, if you would invest that and buy new iPhone 12s when it came out, you would get 80,000 units for the same amount of money. So the price performance increase in compute per dollar or per euro since 1975 is more than 5 billion times, which means that everybody today have a supercomputer in their pocket, which of course would have been seen as completely ridiculous in 1975. So with that incredible price performance, we could start doing new things. But what was one of the most biggest breakthroughs was an open standard called the Internet Protocol, or IP, and that enabled all of these devices with all of these high compute to now communicate with each other. But what we were able to do in Scandinavia was that we actually were the world's first to build a new parallel network so that the new supercomputers, the new price performance wasn't limited by the old telephone wires. So we actually started building fibers. And when we started to build, you had one infrastructure for communication, which was the phone lines. You had another infrastructure for distributing of television. And if you wanted to have high-speed compute, you built yourself a LAN network, typically at the office. What we were able to do was that we showed, even if it sounds counterintuitive, it was actually faster, cheaper, and better to build a new fiber optical parallel communication network than to upgrade the existing phone system. And once internet, the open standard, was combined with this high-speed communication network run by these price performance processors, we were able to do incredible things that was not seen before. We have low fixed cost for all of the global communication we need, and all of these services, telephony, TV, and everything that we do with our computers is now run over one network, and it's a low fixed cost for global communication. This was some of the keystones to the digitalization, and that has had an enormous economical impact. 40 years ago, the European economy and the US economy was about the same size. But because of the Americans have been more clever about how they've created global champions, great companies, through the digitalization, of course, is helping everybody in the world to do everyday tasks, but the Americans were even more clever about how to capture the value from that. So in the last 40 years, the American economy has doubled in size compared to the European economy. And the key advantage was a better utilization of digitalization. Now we're seeing a similar opportunity because as the Intel microprocessor, the 4004, was created in the 80s, now there's a new incredible technology. It's called power electronics. It's been around for a few years, but the important thing with it is that it's now found the same way where it goes up in the amount of power it handles, but also it goes up on this volume. So there's the equivalent of Moore's law for power electronics. And this is because power electronics is a key component in all of the electrical vehicles around the world. It's both in the charger, but also in the vehicle receiving the electrical charge. And what we're now working on, and this is what we call EnergyNet, is the new open standard. This was released 21st of April last year, given to everybody in the world, exactly as the TCP/IP, as an open free standard. Everybody can use it. And the key here is the EP protocol, so the energy protocol. So instead of IP, we now have EP. And this creates an open common language so that electrical devices can now talk to each other so we can send energy to where it's most needed. We believe that this will be the electrification, and this is as a big opportunity as digitalization before us. And in this case, actually, Europe could, if we continue to play our cards right, because of an incredible uh, uh, policy that the European Union put in place, we could actually become the world's intellectual hub on electrification. Because in Europe, we are now allowed to build new parallel electrical grids for and this is the first time anywhere in the world, and this is for all of our EU countries. But of course, it's a combination of digitalization and electrification. The idea that we, based on new cheap ways of producing clean green energy, has been for a long time. And with solar and wind, we've seen that it would be possible to do an energy abundance so that there will be an incredible amount of energy available. And that would, in the same way as an incredible amount of communication, lead to low fixed costs for all the green energy that we need. And this has been described by many authors, including our good friend Amory B. Lovins. Um, and you could summarize it in this picture, basically showing the Industrial Revolution, how that was based on coal, and then came the post-World War modern era that was based on oil and gas. And this is now being replaced with solar, wind, and P2X is basically wind and solar that is time shifted. So this seems to be a very logic step. Why hasn't it already happened yet? There's one final uh, bottleneck. In the same way as the modems and the old telephony system was the bottleneck for bringing us digitalization, the traditional electrical grid is now becoming a bottleneck. And the cost of fixing that would cost trillions of dollars for Europe, trillions of dollars for the US. And what you can see here are pictures describing the amount of queues waiting to be connected to the traditional grid. And you can see Texas is very bright red. 90% of all of these almost 350,000 projects waiting to be connected to the grid, 90% of those are wind, solar, and battery. And this is from the oil state. So there's a problem today with the transformers. The old grid, it's analog, the architecture is way more than 100 years old, and it can only handle a certain amount, typically in Sweden, 20% of local variable production. So it's blocking, just for the Swedish case, it's blocking more. If we would just put solar panels on the roof, it's blocking more than 50 terawatt a year of local green, very cheap energy that will also be super resilient. So by removing this bottleneck, we can immediately have access so that everybody can put solar panels, everybody can put wind, and it will not in any technical way have a negative impact on the traditional grid. So the important breakthrough here, as we talked about, is the European Commission now have allowed, through policies around energy communities, that you could, based on freedom cables, distribute electricity in parallel with the traditional grid. The freedoms you get is that you can choose whatever technology that you want, AC or DC. You can set whatever price for transportation, including zero, and you can set your own price on the local marketplace for power. So this enables us to do an internetification of energy distribution. It can create three very important outcomes. First, we're going to now build an energy system with energy distribution where you do not have any single points of failure. So what the lessons of the war in Ukraine have taught us that even if for all of the other reasons, we cannot have an electrical grid that is so sensitive to disturbances as the traditional grid. And it's going to, because we can now have solar and wind everywhere, and these are very cheap sources, we are convinced that we're going to have low fixed costs for all the clean green energy that we need. And thirdly, and the last outcome is that we're basically going to see that we can now unlock the electrical vehicle promise so that we can run all of our transportations and mobility needs on clean, locally produced, always available local energy. And it's all based on this new open standard that anybody can use. It's called the Energy Protocol. And we think that it will create a better world. And it's going to be much faster than anybody thinks. Thank you very much.